All right, 2.9 is quite a bit easier than the last two problems, so we get a little bit of a break. So what it asks us to do is, starting in the upspin in the z direction, find the expectation values for our three operators, and then the uncertainty for our three operators. And have some reminders over here. Here's our three operators here. Find the expectation value, we sandwich our operator in between the bra and ket of our state. And to find the uncertainty, that's going to be the standard deviation or RMS deviation. It's going to be the square root of our operator squared, or that is the expectation value of our operator squared, minus the expectation value of our operator squared. All right, so let's go ahead and get started. So you can do these in bra-ket notation or in matrix notation. The first one I'll do in bra-ket notation, the SZ, because we kind of know how to do that. The other ones are a little bit more complicated. You'd have to do like outer products, I think. So we'll do those in matrix notation. So first of all, let's do our SZ. So again, we're going to do it in this form here. So we have our bra for our state. We have our operator, so SZ, and then our ket for our state. And so we know, if we cover this part up, we know that if we apply the SZ operator to our upstate, what we get out is h bar over 2, and then our upstate back. Because that was one of the eigenvalues that we found in previous videos. So we know that already. And then so all we need to do is just carry over this, this bra right here. And then we have that. So that's our first step. And then at that point, now we can just pull out that h bar over 2. And then we have up and up. And we know that that's going to equal 1. So that's just going to cancel out. And then we have h bar over 2. So the expectation value for our SZ operator is going to be h bar over 2, which makes sense. So like if it's in the if our state is oriented in the up direction, when we take a measurement, we're going to get up, which is h bar over 2. So then the next one, so our SX operator. So again, we're going to sandwich that with our up state, and we'll do SX and up. Okay, so then in matrix notation, we'll do this time, is the reason why I said matrix notation is easier, because I don't know what we get out of this. If we apply the spin operator for X to our Z up, I don't know what that gives us off the top of my head, so I'll do that in matrix notation. So in matrix form, our up is going to be, this is the bra, so it's going to be 1, 0 in row vector form. And then our SX operator, which is going to be h bar over 2 and 0, 1, 1, 0. And then up in the ket form, it's going to be 1, 0. All right, so let's go ahead and pull out the h bar over 2. We can just do this matrix multiplication first. So we have 0 times 1 is 0, plus 0 is 0. And then we have 1 plus 0 is 1. Then we still have this here, 1, 0. All right, and then we have 1 times 0 is 0, plus 0 is going to give us 0. So the expectation value for SX is going to be 0. So what does this actually mean? Does that mean that if we are oriented in up in the Z, and then we take a reading in the X direction, that we expect to see a 0? No, we'll never see a 0. We can't, oh, goodness gracious. We can't ever get a 0, but we're going to get a mix of negative h bar over 2 and positive h bar over 2. And we're going to get each one 50% of the time. So if you average that out, it's going to be 0, but we'll never get a 0. But the average of all of our readings will end up eventually over time being 0. All right, so we'll do the same thing for SY. So we have our 1, 0, which is our up state. We have our operator, so SY is h bar over 2, 0, negative I, positive I, and 0. And then, again, our up ket. All right, so pull out the h bar over 2. And then we have 0, plus 0, 0. Then we have negative I plus 0 is negative I. And then 1, 0. And then we have 0 plus 0 equals 0. So expectation value for SY is also 0. Again, same thing. We're going to get a mix of negative h bar over 2s and positive h bar over 2s, and that's going to average out to be 0. That's our 3 expectation values. So now we have all these already, and we can square each of those, but we don't know what the expectation value is with our operator squared. So let's go ahead and find those. So again, we can do this in bracket notation because this is going to end up being, so if we want to square the operator, it would be, first of all, our bra state there. Then it's going to be our operator squared, and then our up again. So then that's going to equal up, and then h bar over 2, h bar over 2, up again. And then we can kind of tell that this is going to end up equaling, because we can pull these out. We can pull out h bar over 2 squared, and then up and up. And that's going to be h bar over 2 squared. So I can write that here. So SZ squared, expectation value is going to be h bar over 2 squared. All right, and then so for matrix notation for the other one, so we'll have up, and then let's do SX squared up. So in matrix form, we'll have the bra for up in Z. Then we'll have our SX operator squared. So let's do h bar over 2, 0, 1, 1, 0. And again, h bar over 2, 0, 1, 1, 0. And then our up cat, 1, 0. All right, so what do we want to do first here? Let's just keep this for now, 1, 0. Let's do h bar over 2 squared. And then we can do this matrix right here. So we're going to have like 0 plus 1 is 1. 0 plus 0 is 0. 0 plus 0 is 0. And 1 plus 0 is 1. Okay? And then we'll keep this here. So 1, 0. All right, then we can go ahead and pull out this h bar over 2 squared. I'll multiply these together. So we've got 1 plus 0 is 1. 0 plus 0 is 0. And then 1 and 0. All right, so it looks like we're going to get a 1 here. So that's going to end up being h bar over 2 squared. So our SX squared is going to equal h bar over 2 squared. And we write this here. This is going to be our SY operator now. So do 1, 0. SY operator squared is h bar over 2. 0, negative I, 0. H bar over 2, 0, negative I, 0. And 1, 0. All right, pull out this h bar over 2 squared. We can do our 2 by 2 matrices first. So let's keep this 1, 0 here. All right, so it looks like we have 0. Then we'll have I times negative I, which is 1. Yep. And then we'll have 0 plus 0 is 0. Let's see, so 0 plus 0 is 0. And we'll have negative I times I. It's going to be 1 plus 0 is 1. All right. And then still have 1, 0. So for this one here, we'll keep our h bar over 2 squared. And it looks like we have 1 plus 0 is 1. And 0 plus 0 is 0. And 1, 0. And looks like this is going to equal h bar over 2 squared. So our sy squared expectation value is going to be h bar over 2 squared also. All right, so then now we just need to do our uncertainties right here. All right, so let's start with our sz. That's going to equal the square root of this one right here. So sz squared expectation value is h bar over 2 squared minus our expectation value and then square it. So our expectation value and then square it. So that's going to be h bar over 2 squared. So that's going to be 0. So I'll write that here. So our delta sz is going to be 0. 0. Delta sx is equal to square root of sx squared is h bar over 2 squared minus this squared is going to be 0. And then so the square root of that is going to end up being h bar over 2. So delta sx equals h bar over 2. And our delta sy is going to be the same thing. Right? Delta sy squared was h bar over 2 squared. And then our expectation value squared would be 0. And that's also going to give us h bar over 2. All right, so those are, here are our expectation values, and here's our uncertainties.